People tend to group themselves or their things according to certain similarity patterns. They group themselves because they share a certain interest, or because they belong to a certain category, or simply because they are part of a determined culture. People also tend to organize their things according to certain criteria. These social behavior patterns can also be observed on many online activities. Since we're rapidly moving from a culture dominated by language to one in which visual literacy becomes increasingly important, many ways of managing visual content online have been widely researched. However, until now, there has not been invented an interface that combines automatic classification of visual content and social behavior patterns. Social Collage aims to bridge this gap by offering a platform that allows users to establish connections based only on visual association. It is a visual-oriented website that creates a global collage composed by different squared pictures, built upon visual affinities and user opinion evaluations. The website, shaped as a mosaic, grows infinitely driven by the community. Let's have a closer look to its features and understand how it works. Initially, users can navigate through the collage by zooming in, zooming out, exploring the collage. But users can also be active on the system and contribute to the collage. The first step is to log in. In case you do not have an account, a new one should be created first. Once you are logged in, the possibilities of social interaction appear. You can add friends to your network, check their recently updated pictures, change your own profile, everything that a usual social network website offers. Let's see now how you can contribute with an image to the collage. You click on the upload icon and choose the image. Once you submit the image, the system in return will offer you 20 similar images which are already part of the collage. By clicking once on one of the images suggested, you can check the neighborhood that corresponds to the selected image. Once you decide to position your image on a specific neighborhood, you can drag it over the collage to check the still available positions. If you find a nice spot, just release the mouse and the image will be finally part of the collage. This process is a two-way road. On the one hand, the system helps the user to find the right spot for an image by offering her 20 similar images. On the other hand, by choosing the best spot for the image on the collage, the user is helping the system to learn to which category of images that particular image belongs to. This way, the algorithm learns to consider not only visual affinities, but also social patterns. The users help the system to learn it not only by placing images on the collage, but by voting negatively on the image. When they find an image that is placed on a spot that they don't consider right, they can give a negative vote to that image. Other possibilities are offered to the user, such as linking the image to a page on the web, share the image with her friends, or bookmark the image. So, in an easy and playful way, social collage can be an effective mechanism to review and learn how people establish connections based on visual association.
Now we will look at the technical side of the project. The development of the system was entirely made inside a kind of sandbox, running an instance of Ubuntu Enterprise Server Edition on a VirtualBox machine instance. The Social Visual Collage is a human-computer interaction prototype, subdivided in two independent subsystems. The daemon subsystem is a Python daemon running in the background and encapsulating a content-based image retrieval algorithm. The application subsystem is the concrete web application interacting with the final user. The daemon subsystem offers some services to the application subsystem by implementing a standard interface and making it available in a distributed way through remote procedure calls. Now, we will explore the daemon subsystem in a detailed way. ImageSeek daemon is an open-source standalone content-based image database server, capable of adding content-based visual image searching features to a web application. The currently rapid algorithm uses a multi-resolution wavelet decomposition approach for solving the problem of determining the top k similar images to a target pre-indexing picture. Indexing a single image means computing a signature extracted from a wavelet compressed version of the analyzed picture. Just the wavelet coefficients with the largest magnitude are used, so the results are quite approximative. We can see an example here. This is the original image, and here we have the transformed one. ImageSeek daemon is an open source project, actively maintained by the community, thus it's possible to contribute to the rapid algorithm improvement and expect better results in the future. Our system purposes are actually to design a social container for already existing content-based image retrieval algorithms. We are so not expecting to design a new algorithm. So let's now analyze the main application subsystem. The application is designed using Web2Py, a free open source framework for agile development of web-based applications in Python. As we can see, this framework enforces the model view controller design. Our model is represented by the users, that are the members of the community, the concepts, that are visual classes identifying images, and the images that are stored inside the database table together with the information regarding the picture positioning inside the collage. The controller is responsible of interacting with the daemon subsystem and building the grid representing the whole collage. And finally, the views makes possible to navigate the collage in a user-friendly fashion, uploading images inside the system and positioning them. They are based on simple XHTML, styled by cascading style sheets, and made interactive using jQuery and jQuery user interfaces.